Hi there! Today we have lesson 10.1b, the distance formula. The goal here is to be able to use the distance formula to find the distance between points that are located on a coordinate plane. This right here is the distance formula. It's the equation that we can use to find distance. Notice that there's a very large square root symbol around the whole thing. It looks like we're going to take the x coordinates, subtract them, take the y coordinates, subtract them, add them together, square them, and then finally take the square root of everything. Sounds complicated, but it really isn't. I just want to be sure that we understand where the x and the y's are coming from. Remember, we're going to try and find the distance between 2 points. So if you have 2 points located on a coordinate plane, let's just say that they look like this. And let's say that this point is located here at xy. And this other point here is located at a different xy. If we're trying to find the distance between the 2 points, we have 2 x's and we have 2 y's. So that's where you're going to subtract the x coordinates and subtract the y coordinates. Okay? That's where we're going to be using the formula here to help us out. What I would like to do first is to show you how the distance formula and the Pythagorean theorem are very closely related. Our first example, we're going to suppose that we're given 2 points, these 2 points right here. And we're asked, how many units apart are they? Well, first thing I might want to do is to plot those 2 points on the coordinate plane. You can go ahead and do this with me. -2, 1, here's the 0, 0. So -2, up 1. And then the second point is 1, 5. So start again at the origin, over 1, and up 5. So you see here, I'm asked how far apart these points are. Well, notice that they go diagonally through the coordinates or through the lines on the coordinate plane. So it's really difficult for me to just count how many units apart they are. So that's where I can use the distance formula, but I also want to show you how you could use the Pythagorean theorem as well. Let's first use the Pythagorean theorem, since that's something that we learned just the other day and we're pretty comfortable with. What I can do with this line is create a right triangle. So notice here I have a right triangle that I've just created. Now I can count how many units long this side is, 1, 2, 3. And I can also count how many units long this side is, 1, 2, 3, 4. So this is a 3 by 4 triangle. Now I could use the Pythagorean theorem to figure out how long the diagonal side is. Remember, that's the hypotenuse. So the 3 and 4 would be side A and B, and the diagonal side would be C. So let's go over here and see if we can use the Pythagorean theorem for this. So A and B, those are my 3 and 4. So 3, remember you have to square it, plus side B, which is 4, squared, equals side C, squared. Now remember, my goal here is just to figure out how long side C is. I don't want C squared, I want just C. So my last step here would be to use the square root. And same thing on the other side. So C is the square root of 25, which is 5. So side C, which is the distance between these 2 given points, has a length of 5 units. So that's how I could do this using the Pythagorean theorem. Now what I'd like to show you is how you can do this using the distance formula as well. So in order to use the distance formula, I'm going to start by drawing this very big square root along the entire equation. Looks like I'm going to have to subtract the x's, so I'm going to get ready with parentheses for me to do that. Remember the little exponent too. There we go, everything's set up. Now all I have to do is to find my x's and subtract them. It does not matter which order that you subtract the x's or the y's in, as long as if you're doing it from left to right, that you stay consistent. So I'm going to go back up here to the points. Here I have x and y, and here I have another x and y. Remember, this could be my x1, y1, this could be my x2, y2. It doesn't matter which is which. So what I'm going to do is to subtract the x's, and I always like to move from left to right. So my x here is negative 2. And then I'm going to use the subtraction sign. And my other x here is 1. So I have negative 2 subtract 1. Now I have to subtract the y's. So the y's, this y is 1, subtraction sign, and this y is 5. So I did 1 minus 5. And notice how I did left to right for both of them. Now I'm going to simplify. I have to use order of operations. So remember, order of operations is PEMDAS, parentheses first. So I have to do what's in the parentheses first. Negative 2 minus 1 is negative 3. 1 minus 5 is negative 4. Now the next thing in order of operations after the p is the e. Now I'm going to do the exponent. Negative 3 times negative 3. Negative 4 times negative 4. Okay. Now the next step here would be to add these two together. And 9 plus 16 is 25. But don't forget to bring your square root symbol. So now my last step would be to take the square root of 25, which we know is equal to just 5. So again, I see that these 2 points are 5 units away on the coordinate plane. And what I did here was I used the distance formula in order to help me figure that out. If you notice, looking at the Pythagorean theorem and the distance formula side by side, they're very similar. Notice that we took 3 squared plus 4 squared. We got 25, and then we had to find the square root of that. They're very similar looking at them side by side. All right, let's take a look at example number 2. Here we have a coordinate plane, and you can see that we have the location of point A and B on our coordinate plane, and we're asked to find the distance between A and B. Now, one thing that you could do is to connect these 2 points and see, well, I can't really count the distance because it goes diagonally through the coordinate plane. But you could draw a right triangle and use the Pythagorean theorem. Today, though, because our lesson is on distance formula, I want to practice the distance formula with you. So in order to find the distance between point A and B, I have to have a coordinate for point A and B. And notice here in this example, it wasn't given to me. So I have to name the coordinate for point A. Looks like I go back 4 and down 1. And for point B, if I start here, I go to the right 1 and up 2. So what I did here is just named the coordinates. Now if you'll notice in your notes, I have the distance formula all written out here for you. All we have to do is to plug in the coordinates into the distance formula and figure out what the distance is. So let's go ahead and do that. Notice here that we want to subtract the x's. So I'm going to find my x's. Here's 1, and I'm going to subtract them. So I always just like to do left minus right, left to right. Remember, you have to stay consistent whichever way you do it. So negative 4, subtract 1. The subtraction sign was already there for me. Now I have to subtract the y's. Negative 1, subtract 2. Now, following order of operations, I can go ahead and do the parentheses. Negative 4 minus 1, negative 1 minus 2. Now I'm ready to square. Negative 5 times negative 5. Negative 3 times negative 3. Now what I'd like to do is to add those two together. 25 plus 9 is 34. So my last step would be to find the square root of 34 to get a close distance. Remember, that's an irrational number. However, if you take a look at the answer choices, do you see how the answer choices are given as exact numbers? If the distance is the square root of 34, I see over here that one of the choices is the square root of 34. So I could just go ahead and circle that. But if it wasn't given to me as an exact square root of 34, then I could use my calculator to evaluate it. All right, let's take a peek at number 3. Again, here we're asked to find the distance between 2 points, A and B. We're going to practice using the distance formula. So first thing we would have to do is to name points A and B so we can actually have coordinates to work with. So point B, to the right 4, down 2. that'd be negative 2. Then A to the left 4 up 2. There we go. I've named both of the coordinates for those 2 points. Now let's take a look and see if we can find the distance between the 2 points. So I'm going to start by writing the distance formula. This is a formula or equation that you don't have to memorize. It will be on your formula sheet when you take the MCA test. Remember, we want to take the x's and subtract them, square that, and add it to the y's after we subtract them. That whining you can hear in the background is the puppy I'm babysitting. Okay, so let's try this. Let's subtract the x's. So I'm just going to circle these x's up here so that I kind of keep them in mind. So I've got x here, negative 4, subtract 4. And then we want to square that, plus sign. Now let's do the y's. Here's a y, here's a y. Again, left to right. 2, subtract negative 2. So 2, subtract, and then this one's negative 2. Gotta be careful for that. Now the next step we'd want to do here is to evaluate what's in the parentheses. So negative 4 minus 4 more will be negative 8. And then 2 minus negative 2, that changes to plus, that would be 4. Okay, we got to go down a little bit more here. Negative 8 times negative 8 is 64. And 4 times 4 is 16. So if I add these two together, I get 80. So I have the square root of 80 as the distance between the 2 points. However, if you notice the choices here, there isn't anything that says square root of 80. That doesn't mean that you have the wrong answer. Square root of 10 is definitely not the square root of 80, so we can say that that's not it. Now, square root of 80, you guys know that the square root of 81 that comes right after this is 9. So this is right before 9. So it's going to be really close to 9, like 8.9, approximately 8.9. It's irrational, but if you type it in the calculator, you're going to get about 8.9. So we know it's definitely not 8, because 8 is the square root of 64. Now we have these two. Do you notice how the 4 is stuck to the square root of 5? That means it's multiplied. So here we have 4 times the square root of 5, or 4 times the square root of 3. Now, which one of these is equivalent to approximately 8.9? So what you could do is you could put them in your calculator. Type in square root of 5 times 4 and see what it says. Type in square root of 3 times 4 and see what that one says. So if I do that, 4 times the square root of 5, it is approximately 8.9, while 4 times the square root of 3 is about 6.9. So because C is closest here, we're going to go ahead and we're going to choose C. All right, let's take a look at number 4. Here we have Lauren traveled from this point on the coordinate plane to this point, and then from there, she went to this point. What is the total distance that she traveled? Well, it looks like we've got 2 places where we're going to have to find the distance formula. Do you notice that? Let me draw a little picture to show you what's going on here. So Lauren's traveling from this point to this point. So here, if I draw that, I have this point, negative 1.5, comma 3, and she's traveling to a different point, and we're going to name that point 7, negative 3.5. Then from there, she goes to this point. So from here, she's going to go to another point, and we'll call that point negative 5, comma 2.5. Now, I know that my picture isn't drawn to scale, and it's definitely not where these would be located on a coordinate plane, but I just wanted to give you an idea of what's happening here. So she starts here, she travels to this point, and then from there, she travels to another point. So do you notice here how we're going to have to use the distance formula twice? Using the Pythagorean theorem for this is definitely not going to be the best way. So here I'd have to use the distance formula once to find this distance, and a second time to find the distance between here and here. And then to get the total, I'd have to add them together. So let's go ahead and attempt this. Notice we've got some decimals, so we're going to have to be careful. So let's begin with finding just the distance from here to here, and I'll do that in green. So getting ready here with the distance formula, I'm going to take the x's, the two x values, I underline them here and here, and I'm going to subtract them. Remember, here's our distance formula if you need to look at it up there. So I've got negative 1.5, subtract 7, squared plus, now let's go ahead and do the y's. So here I have 3, and I have negative 3.5. So again, 3, subtract a negative 3.5. And then squared. Things are getting a little scrunched down here. Okay, so here I have negative 1.5 minus 7 more. And you could use a calculator for this, but I know I'll have at this point negative 8.5 squared. Now 3 minus a negative 3.5, that's the same thing as adding. So I have 3 plus 3.5, which is 6.5, and then squared. Now you should be able to type all of this into the calculator, on that calculator on your Chromebook for the MCA. You should be able to put your parentheses and type everything in there. Maybe not the square root on the outside, but everything else in here. So I just typed all of this into my calculator, and it says 114.5. Now my last step would be to take the square root of 114.5. My calculator says approximately 10.7. So it looks like from the distance from this point to this point, it's approximately 10.7 units. Okay, well I'm halfway there. Now I need to find the second distance. So I'm going to get ready again with the distance formula. And this time I'm going from this point to this point. So you see how helpful maybe a picture is. So again, I want to subtract the x's. So here I have a 7, subtract, and this is a negative 5. 7 subtract negative 5. Now I want to subtract the y's. So here I have negative 3.5, subtract, and here I have a 2.5. Running out of room again. Okay, well I know that this means add. So this is 12 squared. And if I have negative 3.5 and I subtract 2.5 more, that's going to give me negative 6. You could type it into a calculator also. Okay, now I'm ready here. 12 times 12. Negative 6 times negative 6. Okay, then if I take 144 plus 36, that's 180. And then if I just use my calculator to type in the square root of 180, it's approximately 13.4. So obviously my picture is not drawn to scale here. So the distance from here to here is about 13.4 units. Now remember, we were asked for the total distance. So now we're going to need to take both of these distances that we found and add them together. So if I take 10.7 plus 13.4, then I'll get the total distance. So if I add these two numbers together, I get about 24.1 units. So that would be the total distance that Lauren traveled. Quite a bit of work for that one, but now you'll be prepared for it. All right, I like this next one. Here it says the endpoints of AB, and AB is a line, are these 2 points. And here we have the endpoints of line CD are these 2 points. We are asked how much longer is line AB than CD. This is almost impossible without a picture. So let's take the coordinates that we're given and put them onto a coordinate plane so we can get an idea of what this actually looks like. So if you want to pause the video, you can to go ahead and graph them, or you can graph them along with me. Let's first do line AB. I'm going to do this one in purple. So I'm just going to graph these 2 points. Once I have the points graphed, I'm going to connect them. Remember, this one was line AB, so I'm going to name this A, B. The second one is line CD. I'm going to do that one in red. So I'm just going to graph these 2 points. And then I'm going to name it CD. Now we're asked, how much longer is AB than CD? And you can tell from the picture that AB is definitely longer, and we're asked to find out how much longer. Well, if you look at line CD, you could easily see how long that is. Because it is horizontal, you can just count the units. I count 9 units. So there we go, I have the length of CD. Very simple. Just by drawing a picture, I know that I don't have to use the distance formula to figure out the distance here. But because this is diagonal, I do. Now you could use the Pythagorean theorem, maybe create a triangle and do that, but I want to practice the distance formula, so we're going to use the distance formula. So remember, I'm trying to find the distance between A and B. So to remember that, I'm just going to circle these points so I don't forget that this is what I'm doing. Let's find the distance. Remember, the first thing I want to do is to subtract the x's. So I have 5, subtract -6. Now I'm going to subtract the y's. 1, subtract, oh, there's a -5. 2 double negatives. Now I'm going to evaluate what's in parentheses. (11 times 11), 6 times 6. Now if I add these two together, I get the square root of 157. I'm going to want to approximate that. It's irrational, so I use my calculator, and the calculator says it's approximately 12.5. So the distance between A and B is about 12.5 units. Now remember, the question asked us, how much longer is AB than CD? So think about what your next step would have to be here. You'd have to subtract them. Or just, do it in your head. How much longer is 12.5 than 9? So if I take 12.5 and I subtract 9, remember that's 9.0, you could use a calculator or not, and you get about 3.5 units longer. So here is my solution. All right, and here we are on the last one, number 6. Here we're asked to approximate the area of the triangle. Well, it's first going to be important that you know how to find the area of a triangle. Here we have a right triangle. Now I know that you haven't maybe found the area of a triangle since 6th grade. This was something that was on your 6th grade formula sheet. Well, remember here that if I want to find the area of a rectangle, I take the base times the height. But that's going to give me the entire area of a rectangle. And a triangle is half of that. So what I want to do is take my base times my height, and then to get rid of this half, I divide it by 2. So the area of a triangle is taking the base times the height and dividing it by 2. Well, notice down here that I have the length of the base. It's 7 feet. But I do not have the height of the triangle. So I have to find that. Well, they tell me what the hypotenuse is here. And being that this is a right triangle, I could use the Pythagorean theorem. So here's my side A, my side B, and my side C. We're going to have to find side A or B. So let's use the Pythagorean theorem. A is my unknown. B is 7. C is 9. I just evaluated 7 squared and 9 squared. Remember, the goal is to get the A by itself here. (81 minus 49), you can use your calculator for that if you need to. Now remember, the last step is to take the square root of both sides to get just the length of A. Now, square root of 32, that's irrational. So if I use a calculator, I can say that it's approximately 5 point, my calculator says it's about 5.6568. So maybe here I want to go 2 decimal places. Well, to figure out if this is going to stay a 5 or bump up to a 6, I'll have to look at the next number. It's bigger than 5. So we'll go 5.66. Make that 5 bump up to a 6. We'll say that's approximately how tall this is. So A is about 5.66 approximately. Okay, now in order to find the area of the triangle, I have to take the base times the height and divide it by 2. So my base is 7, and my height is 5.66, and then I want to take that and divide it by 2. So again, you're going to need to use your calculator. Well, when I use my calculator, 7 times 5.66, and then I take that answer and divide it by 2, looks like I get approximately 19.81, and notice this is feet, so feet squared is my area. That would be the approximate area of the triangle. And there we are. We're finished. Have a great day. Thanks.